Okay, so question 2 is looking at rationalising the denominators of a third. However, there's this root 20 at the top there, which can end up being simplified. Now, I'm not going to end up simplifying that until right at the very end. I'm just going to go through the normal method of rationalising denominators to begin with. So, always start off with 3 plus root 20 over 3 plus root 5. When we're rationalising a denominator, we need to multiply by the conjugate of the 3 plus root 5. So we've got 3 minus root 5 over 3 minus root 5. There's two reasons why we do that. Technically, we're multiplying by 1, because it's the same thing divided by the same thing, but we're also, when we expand the brackets at the bottom, or expand the denominator out, the roots are going to end up disappearing, so that's rationalising the denominator, getting rid of the square roots. So if I was going to expand these out, I'm going to put it all over one fraction, 3 plus root 20 multiplied by 3 minus root 5, and then on the bottom it's going to be 3 plus root 5 multiplied by 3 minus root 5. And if I go through and expand out the top bracket, so I'm going to end up with 9, take away 3 root 5, plus 3 root 20, take away 10. And then on the bottom, I'm going to end up with 9 plus 3 root 5 minus 3 root 5, take away 5. And then if I end up simplifying everything I can at the moment, so I've got the 9 minus 10, so that's going to give me minus 1. And I've got minus 3 root 5 plus 3 root 20. And then on the bottom you can see that the plus 3 root 5 and the minus 3 root 5 cancel out, so we just end up with 9 minus 5, which ends up giving you 4. So at the moment it looks like I've simplified it as much as I can, but I said right at the start of this video that we've got root 20 which we can end up simplifying. So if I go ahead and simplify that root 20, square root of 20 I could write as the square root of 4 times the square root of 5, which then simplifies to be 2 root 5. So then my next line of workings, I've got minus 1 minus 3 root 5 plus 3 times 2 root 5, all divided by 4 still. And then carry on working this through, so I end up with minus 1. If I put all of these root 5s together, I've got 6 root 5 there, I've got minus 3 root 5 there, so I'm going to end up with just 3 root 5, so plus 3 root 5, and then that's still divided by 4. And then I can end up simplifying this and putting them as separate fractions, so we would end up with minus a quarter plus 3/4 root 5. And then I've simplified that, it's in the form a plus b root 5, because I've got a is minus a quarter and b is 3/4. You don't actually have to state what a and b are. If it's in that form, then you've implied what a and b are from your answer.